Hi, a very good day to everyone. We are from Group 5 and today we want to present about the experiment 5, which is measurement for the jet force. So I am the group leader, Hui, and our group member have FARAH, JING, and also RANJEET. So first and foremost, we will introduce the theory for this experiment. According to the Newton's second law of motions, a jet of fluid when impinging upon a flat plate or a hemispherical surface will generate a force due to the change of the momentum of the fluid. For example, a velocity of the water from the water jet's nozzle with the diameter strict on a flat plate or a hemispherical surface, the rate of change of the momentum produced and its magnitude is the same with the force exerted on the surface for the flat plate or the hemispherical to support the water jet. So the force generated by a jet of the waters when it strikes depends on the shapes of the surface where we have the flat plate or the hemispherical surface. So this figure 1 and figure 2 depict a jet of fluid issues from a nozzle for diameter moving vertically upward with velocity, where this velocity is called as V1 and strike a flat plate and a hemispherical surface respectively. So the jet is deflected by the surface of a flat plate or hemispherical space through an angle and leave the surface with velocity v2. So the theoretical force generated when the jet of fluid strikes a flat plate is equals to F is equals to rho a v1 square minus rho a v2 square cos theta, where here the velocity is vertically upwards. So the theta is equals to 90 degrees. So v2 cos 90 degrees is equal to v1 and equals to 0. So from the equations 1, it can be simplified as F is equals to rho a v1 square. And then for the hemispherical surface, the theoretical force is generated as F is equals to rho a v1 square minus rho a v2 square cos theta. Here the theta is equals to 180 degrees. So v2 cos theta is equals to negative v1. Then from here, the equation 3 can be simplified as F is equals to 2 rho a v1 square.
Hi, Assalamualaikum. My name is ELENNA binti KAMARUZAMAN. Now, I will be discussing on the summary report. So, let's look at the slides. So, first of all, this experiment aims to compare the force exerted by a fluid jet impinging upon a flat plate or hemispherical surface with the theoretical values. According to the Newton's second law of motion, the change of water fluid momentum affects the force produced from the flat plate and hemispherical plate, while the water fluid momentum is depending on the shape of the surface, whether it is the flat plate or the hemispherical plate. This time, the experiment needs to consider volume of water collected, which is a constant 2 for both flat plate and hemispherical plate, the time taken for the water to be fully collected, the flow rate, which is the Q actual, the velocity of the water jet, theoretical momentum force, measured force for both surfaces, and the percentage of relative error. Next, I will be presenting on the result. In this experiment, we considered the measured force, the volume of water collected in liter, which is a constant of 2 liters, the time taken of the water to be fully collected, the flow rate, which is Q actual, the velocity of the water jet, the theoretical momentum force, and lastly, the percentage of relative error. In table 1 is the data for the flat plate. The flow rate is calculated by the volume of water collected over the time taken. The velocity is calculated by flow rate over the area of nozzle, while the theoretical force is calculated by the force theory equal to rho times area of nozzle times v squared, And the percentage of relative error is calculated by measured force minus the theoretical force over the theoretical force and times 8 to 100 to get the relative error in percentage. In this slide is the table 2, which is the data for the hemispherical plate. So that is how we calculated the values for the result in table 1 and table 2. That is all from me. I'll pass to the next presenter.
My name is Jing and I'm going to present the first question of discussion, which the first part will be plot a graph of log measured force versus log V for both the flat plate and hemispherical surface on the same graph. So to start this question, we need to log the both values of measured force and the velocity. After we get the value for both log measured force and log V, we can plot the graph. The two tables shown here are the data for flat plate and hemispherical surface respectively, and this is the graph of log force measured against log V for flat plate and hemispherical surface. And next we will proceed with estimating the slope of the graph for both flat plate and hemispherical surface and compare with the theoretical value as shown in equation 2 and equation 4 respectively. Comment on the difference. The slope of the graph for both the flat plate and hemispherical surface are shown below. For the flat plate, we will be using equation 2, which theoretical force equals to rho AV square. After we add log to both sides, we get log theoretical force equals to 2 log V1 plus log rho A, and the same things go with the hemispherical surface, which using the equation 4. The equations above can be found related with the equation of line, which y equals to mx plus c, where log rho A and 2 log rho A represents the y-intercept, and 2 log V1 represents the slope for flat plate and hemispherical surface respectively. And for theoretical slope for both flat plate and hemispherical surface, we will be using the equation which m equals to y2 minus y1 over x2 minus x1. After the calculations, we get the experimental slope for flat plate is 1.7006 and 1.8415 for hemispherical surface. And the theoretical slope we get for flat plate is 1.9995 and 2.0023 for hemispherical surface. The difference between values of theoretical slope and experimental slope may be caused by errors while conducting the experiments and the difference in the force impact towards the surface of the plates due to different angle of water impaction. And for part B, estimating the y-intercept ratio of hemispherical surface to flat plate and compare with the theoretical ratio as deduced from equation 2 and equation 4, comments on the difference. So for flat plate, we will still using the equation 2, which theoretical force equals to rho AV square. After adding log to both sides, we get log theoretical force equals to 2 log V1 plus log rho A, and the same things go with hemispherical surface using the equation 4. The equations can be found related with the equation of line, which y equals to mx plus c, where log rho A and 2 log rho A represents the y-intercept for flat plate and hemispherical surface respectively. The ratio of y-intercept of hemispherical surface to flat plate is calculated as follows. For the theoretical one, we will be using log 2 rho A over log rho A, and we get the value 0.7276. And for the experimental one, we using y-intercept of hemispherical surface over y-intercept for flat plate, and we get the value 0.7584. So we can obviously see that the experimental ratio is greater than theoretical ratio. This difference may be caused by major and minor loss of the fluid when going through the pipe and striking the plate. And for part C is comparing the force exerted on the hemispherical surface with the one on the flat plate, which one is greater and why. The force exerted on the hemispherical surface is greater compared to the force exerted on the flat plate. The force exerted on hemispherical surface is higher due to the change in momentum on hemispherical surface is bigger than the change in momentum on the flat plate. This happens when the water jet from the nozzle hit the hemispherical surface with 100-degree angle of the surface. Higher energy is produced which enable the water reverse to its direction. The momentum and total energy exerted increase due to high impact of velocity and lead to shorter time taken to hit the water on the hemispherical surface. While for flat plate, the velocity is 90 degrees to the left and to the right after impacting the flat plate. When the water jet reaches the surface of the flat plate, lower energy is released. Longer time taken to hit the water on flat plate. The force impact on hemispherical surface can be proven 2 times larger than the force impact on flat plate from equation 2 and equation 4. And for flat plate, the force will be rho A V square, and for hemispherical surface, the force will be 2 rho A V square. So that is all from me. I will pass to the next presenter.
Hello everyone, I'm Ranjit. So here I'm going to discuss about the question number 2. So the question is, compare the percentage of relative error for both the flat plate and hemispherical surface as function of jet velocity. Comment on the analysis and explain your reason. So from the table we have obtained that for flat plate the lowest percentage relative error is 1.48% and the highest one is 25.62%. So by calculating overall the percentage of relative error, we have obtained that average percentage relative error for flat plate is 14.28%. So meanwhile, for hemispherical surface, the lowest percentage relative error is 1.36% and the highest one is 25%. And lastly, the average percentage relative error for hemispherical surface is 10.93%. So based on the analysis, the percentage of relative error calculated for both flat plate and hemispherical surface is not stable and inconsistent by overall. Due to the uneven shape of hemispherical surface, the redirected force of the jet is not uniform and reflected back to the main jet water stream. For the flat plate, the relative even shape of its surface is more uniform when water strikes on it. The other errors that may happen in the experiment will result in inconsistency of results. Next, the spring coil should be held in a standard position to ensure the velocity of water strike on it is more precise. This is because different angle may cause the different force exerted on the surface. Lastly, the external weight applied on the balance causes the imbalance of force. That's all from me. Thank you.
Hi, I'm Kohui, and now I'll continue the presentations with the question 3. Briefly discuss on the factors that contributing to the error or inaccuracy in experiment data, and the possible recommendations to improve the existing result. So there are some factors that contribute to the error or inaccuracy in the experiment data. So first and foremost, we have the systematic error. Systematic errors will give the measurements that are consistently different from the theoretical values. So it's often due to the limitations of either the instruments or the procedures. So this type of the systematic error is also considered as one form of the bias. Secondly, we have the parallax error. So this type of the errors may occur when the observer eyes was not aligned with the water levels when the observer collects the required reading data. So in order to prevent the parallax error to occur, the observer eyes must be at the same level with the molecules of water when collecting the reading data. Next, we have presence of the air bubbles in the system. So the presence of the air bubbles will make some slight change of water level in the volumetric measuring tank. Thus, it will affect the accuracy of the manometer readings. So in order to improve the existing result, the valve must be opened fully for a while at the beginning for the experiment to release all the bubble inside. Moreover, we also have the flow control valve. So this flow control valve may not fully open. This error will cause the velocity of the water less than the theoretical value. So the flow control valve must be fully open when the experiment was undergone. Next, let's move on to question 4. Suggest 2 applications of jet impact in industry. So one of the applications of jet impact in industry is we use to generate the electricity. The jet impact is used to rotate the turbine, where we name the turbine as Fulton wheel in generator. So the water jet is applying the force tangential to the wheel. So this tangential force of the water jet, it will generate a moment on the wheel to its maximum value. Therefore, the mechanical energy of the Fulton wheel was increased, and this rotational energy of the wheel is then converted to the electrical energy. So secondly, we will continue with the next applications of jet impact in industry, where it was the water jet cutter. So by using the high pressures and high velocity of the water jet together with the abrasive substances, the water jet cutter is able to slide the metal or other materials. So the process of the water jet's cutting is similar to the water erosions that found naturally, but this process will occur with highly accelerated and concentrated. Next, we'll move on with the conclusions. So from the experiment, we can observe that the average slope experimental value for the flat plate force is 1.7006 compared to the average slope's theoretical value of the flat plate force is 1.9995. So while for the average slope experimental value for the hemispherical plate is 1.8415 compared to the theoretical value for the hemispherical plate is 2.0023. So the theoretical value we can calculate by using the formula given. And then the difference between the theoretical value and the experimental value is because there may be some errors that occurs during the experiment. So to conclude all, the force exerted from the flat plates will be lower than the force exerted from the hemispherical plates. So that's all from our group 5. Thank you.